outdoor and indoor, and GIS. GIS is gas insulated substation. GIS is gas insulated substation. That is, gas insulated substation means SF6 gas insulated gas we are providing. Outdoor substations above 36 kV, above 33 kV we have to go for outdoor substation. Indoor అయితే 33 kV మాత్రమే వర్క్ ఉంటాయి. Outdoor conventional air insulated substation, that is outdoor substation తో సార్. Mostly we are 66 below అయితే ఇవి వాడతారు. Indoor substation 66 kV below. Outdoor we prefer because insulation problem solved. It is a single line diagram of general substation. Okay, it is 400 kilovolts Akra switching station. It is single line diagram. We can see the single line diagram means these are bus 1, bus 2, or two buses are connected, and 400 kilovolts outgoing, Gwalior 1, Gwalior 2, like that. Whereas outgoing lines are these. Jaipur 3, Jaipur 3. This is going to different feeders we are connecting to this bus bars. This is the bus 1, bus 2. Bus 2 is connected to different areas. This is one of the feeder going to another area. This is another area feeder. It is 400 kV substation in India. You can see this is another feeder, single line diagram only. What are the various equipments in the substation? You can see that it is a bus bar 1 and bus bar 2. We can see the diagrams also. Circuit breaker is indicated by like this, and current voltage transformer CVT, that may be a current transformer and potential transformer. This is CT. Lightning arrestor indicated by like this arrow mark, and this is filter or distribution switch. What are the equipments in substation? If you know, you can easily understand this diagram. This is the distribution transformer or power transformer location. It is circuit breaker. This is the circuit breaker. This is the filter and earthing switch, isolator. Here we provided isolator. Again, it is a CT. It is CT. Both sides of the transformer we provided CTs, again CTs, and earthing and bus coupler. It is a bus coupler. Like that, various equipments will be connected in any substation. Let us discuss each and every equipment briefly. Okay, first equipment already I told you, the first equipment which we see in substation is lightning arrestor. Lightning arrestor is a device used on electrical power system to protect insulation on the system from the damaging of lightning. To protect against lightning and over voltages, we are using lightning arrestor. Lightning arrestor function you studied in power system protection. What are the various types of lightning arrestors? Zinc oxide and metal oxide. What is rod gap, horn gap? So many lightning arrestors you studied. Metal oxide lightning arrestor. Metal oxide lightning arrestors have been used for power system operation protection since 1970 onwards. It is also known as surge arrestor. Metal oxide, a lightning arrestor may be also known as surge arrestor. We can use current from the surge is diverted to the ground and protect the costly equipment which are in substation. It is the first equipment which we can see in the substation from the transmission side. Starting of the substation, if you enter a feeder is entering the substation. That feeder is connected initially to lightning arrestor. This is pictures of surge diverter or lightning arrestors. Already, what is how lightning arrestor works? This is one type. This is based on this number of discs available. You can use the lightning arrestor. This is also lightning arrestor for high voltages. This guard ring it is. One video also I made in this channel actually. What is lightning arrestor? How it works. Next, capacitor voltage transformers, CVTs, these are. Coupled voltage transformer, CCVTs. The diagram representation is. It seems to be a lightning arrestor, but the color of this lightning arrestor is different. It has number of porcelain disc insulators. But the CVT, capacitor voltage transformers or coupled voltage transformers, capacitance coupled, to step down extra high voltage signals and provide low voltage. Protective relays operate cheyadaniki in the transformers substation. To operate the protective relays, we have to step down the voltages. But the actual thing is 33 kV substation supplies the 33 kV to some other substation or distribution transformer. In there 33 kV is stepped down to 440 volts. But in substation they require low voltages. Therefore we are using capacitor voltage transformers for measurement operate of protective relay. Protective relay operate అవ్వడానికి ఖచ్చితంగా సబ్స్టేషన్లో బ్యాటరీస్ పెట్టుకుంటారు. అవే కాదు చిన్న చిన్న రిలేస్ ఉంటాయి, ఆ రిలేస్ ఆపరేట్ అవ్వడానికి కూడా. నెక్స్ట్ it is earthing switch. Earth switch is used to discharge the voltage on the circuit to the earth safety. What is the purpose of earthing is, if any person touches the live wire or contact wire, the earth resistance is very low compared to human resistance. Therefore total current will passes through earth whenever fault occurs in a transformer. If assume that it is a transformer, if you touch it, it won't give shock actually. Whenever fault occurs in the transformer, earth fault, there are so many types of faults occurring. You study in power system protection. What are the various types of internal faults, external faults, like that. Or if you consider what are the equipments in substation. Transformer ఏదైనా ఫాల్ట్ వచ్చింది అనుకోండి, ఎర్త్ ఫాల్ట్, అన్నోన్ పర్సన్ టచ్ చేస్తే చనిపోయే ఛాన్స్ ఉంది. అందువల్ల ఈ గ్రౌండ్ సిస్టమ్ ఉంటే టోటల్ కరెంట్ ఫాల్ట్ కరెంట్ విల్ పాసెస్ త్రూ గ్రౌండ్ బై యూజింగ్ ఎర్త్ స్విచ్. Line trap, you can see this like a umbrella, a line trap is there. Like an umbrella, a line trap is there. You can see connected in series with the line, a power transmission line. It blocks the high frequency carrier waves because the frequency level of in substation is 50 Hz only. But to protect high frequencies more than 50 Hz, 24 kHz to 500 kHz, actually our power frequencies are 50 to 60. But to block high frequencies we are using line trap. Line trap means it's a inductor. Inductor does not allow high voltages. There are three main components. Main coil, it is a inductor. Lightning arrestor also it consists. And turning device, three parts are there. But basically it is a inductor of rating millihenry and blocks the high frequencies. Okay, wave traps similar to umbrella. You watched that substation previously. అక్కడ ఒక అంబ్రెల్లా లాగా ఒకటి పెట్టినారు, లైన్ ట్రాప్స్ అని చెప్పారు. అప్పుడు మీకు తెలిసిందో తెలుస్తుంది అది. నెక్స్ట్ ఐసోలేటర్ ఇస్ a switch, simply open and close. Disconnector or isolator, switch used to make sure that electrical circuit can completely de-energize for service and maintenance. By opening the isolator, totally we can do operations in substation, any services. Isolator means it is a switch or disconnector it is. What is the difference between circuit breaker and isolator? Isolator can operate manually, whereas circuit breaker operate automatically. That is the main difference. Disconnector or isolator is a switch used to make opening and closing operations under maintenance service. Isolator is an off-load device. You have to remember that transformer tap changing or on-load tap changer, off-load tap changer, there are so many types. One is isolator is an off-load. Off-load, when we have to switch off the load or remove the load, after that we have to disconnect the supply. Off-load means we have to disconnect the load after that. Suppose on-load, if we open the isolator, these are the connecting rods of isolator. On-load, if you open the isolator, what will happen? High currents are passing in the contacts. Actually, these are the contacts while passing high currents. Whenever you suddenly break the switch by using this isolator, at that moment large sparking will appear. That may cause harmful for person who is operating it. The types of isolators, there are so many types. Isolators are central rotating, horizontal swing, central break. There are so many types, but isolator is a off-load switch, whereas circuit breaker is a on-load and automatic device, automatic switch it acts as. Isolator is a off-load, remember that, okay. Next, current transformer. Everybody already you studied measurements. What is current transformer? For protecting and measuring, we are using current transformers. Current transformers are instrument transformers. A current transformers, how to identify in a substation is already the substation engineer told that how to remember current transformer. A current transformer will be like this. Assume that it is a diagram. It is connected in series with the load. Hence, it consists of two terminals. One this side and another is connected to directly. But potential transformer are not like that. Okay. Current transformers are two types, protective CT and measuring CT, two types. One is the protective CTs are using in relays. Measuring CTs are using in meters. For metering purpose, we are also in potential transformer. For protection also, if I use current flows, what is the operation of relay? Power system protection you studied. The relay how to operate? By use of CT only senses the fault current and operates. Measuring purpose and protective purpose, we are using current transformers. Circuit breaker, as usually what is the circuit breaker? It is a automatically operated electrical switch. A circuit breaker can make or break the circuit whenever fault occurs. Whenever you want to manually operate also, you can operate the circuit breaker manually when there is no fault. If you want to open under loaded condition also, we can switch off the circuit. A circuit breaker automatically operated switch designated as to protect electrical circuit from any excessive or short circuit. That means circuit breaker can operate in off-load condition, on-load condition, whatever be the condition, because circuit breaker totally equipped with oil always. If any fault occur, circuit breaker automatically trips. If you want to do service of substation, some equipment, you can open the circuit breaker by remote also. This is a circuit breaker symbol also we discussed. These are the circuit breakers. Some students are taken the photograph of SF6 circuit breaker. SF6 circuit breaker, you taken the photo of some of the girl students are taken. The SF6 circuit breaker, some photo also. These are the circuit breakers like this here. But in substation, in our substation, it is not the same height, but compared to this, less height. Different techniques are used to extinguish the arc in circuit breaker. Arc extension in beam, bulk oil, minimum oil, air blast, SF6. We saw the SF6 circuit breaker previously. What is SF6? Sulfur hexafluoride. Vacuum circuit breaker, air brake circuit breaker. So many types we studied. Next, another equipment, important equipment is bus bar. All the incoming lines, outgoing circuits are connected to bus bar. Bus bar is a hollow structure and mechanically strong structure. If you are using wires, wire may be melted, but bus bars are mechanically strong and they are not melted. But if any fault occurs, bus bar, entire substation, outgoing lines, incoming lines will be disturbed. Hence, bus bars are the important equipments in substation. Power transformer, as usually used. Some students also taken the pictures in this transformer also. Power transformer equipped with large size, hence cooling we provided fans, not only breather also. What is this? Conservator used to cool the transformer, but also we are provided with the fans, and these are the bushings, breathers. So many protective devices are using. Power transformers are used to step up or step down AC voltage in power substations. It is a very important equipment. Based on this power transformer, the rating of substation will be there. Rating, దీని మీద బేస్ అయింది. మన ట్రాన్స్ఫార్మర్ ఒక 33 kV ట్రాన్స్ఫార్మర్ ఉంటే that is 33 kV substation. If the transformer is 220 kV transformer, input output is 33 kV, then it is a 220 kV substation, like that. Based on the equipment in the present in substation, we can decide it is a Rating, what is the rating of substation? Rating also depends on power transformer. Next, reactors. Reactors rating in the switchgear and protection, diploma students, those who studied reactors, reactant voltage, reactor rating also. Shunt reactors are used for long EHV transmission lines to control voltage during low load period. Compensate the shunt capacitance of transmission line during low load periods. This is the important. Shunt reactors used to compensate shunt capacitance in transmission line. Reactors are transmission substations, we are using reactors. Reactors are dome type vessels and these are inductors actually. Inductor is nothing but reactor. An inductor will be like this. The rating also you studied in diploma also you studied, but you studied or not I don't know. The reactors, how it will be. Series reactors, these are to limit the short circuit current and limit the current surges. Series reactors, shunt reactors, the power system, it is also one of the part in a substation. Series reactors are used to limit the short circuit current, to limit current surges. Series reactors are located at the strategic locations of the fault levels are reduced. If the fault occurs, huge fault current can be objected by the series reactors, whereas shunt reactors are used to reduce the shunt capacitance effect. Shunt capacitors to improve the power factor, to improve the voltage level also by improving the power factor. Shunt capacitors we are using. They are connected as shunt. In our EDS, what is the difference between shunt and series capacitors? We will study. Shunt capacitors are used for compensating reactive power of a low power factor. They are used to improving the power factor. In substation also, we are using shunt capacitors, old series capacitors also, but series capacitors installation problem will occur. Shunt capacitors are improve the voltage level by improving the power factor, whereas series capacitors directly inject the reactive power. Series capacitors. What is the difference? All this will be in unit 4 in electrical distribution system. It is series capacitor. Okay. ఇక్కడ నేను పాస్ కొట్టాలి. పాస్ కొట్టిన okay, grounding equipment. Earthing and grounding is rod earthing, pipe earthing, so many methods we are using. These are the neutral earthing, neutral grounding equipment we are using, but in distribution transformer neutral will come, but not in substation. Actually power substations or generating substations, neutral will not be there. And if you see the transmission line, neutral will not go, but one earth wire will go, and top of that ground wire it is. Other switchyard equipments are, these are the other switch of power cables, control labels, marshalling, cooks, kioscos, power cables, control cables, insulators are important, metering, relays and control panel. Okay, metering, relay and control panel purpose we are using battery, UPSs, supply systems. These are other switchyard equipments. Power line carrier communication. It is also you studied in PSP, power system protection, to protect telemonitoring, communication, PLCC, carrier current protection you studied with. What is SCADA? All this will come in unit 5. Next, bus bar. What are the various types of bus bars? Single line, single bus bar system, double bus bar system, bus bar connection schemes. What are the advantages of double bus bar? If any fault occur in one bus, another will be there. But different connection schemes also one of the topic we will discuss. We made another video based on double breaker system, double brake, double bus system it is. If any one of the bus fails in previously double bus system, suppose if this breaker fails, this bus bar fails, this is the bus bar protection methods actually. If any bus bar fails, we can connect and through another bus bar, we give the supply for feeder. Okay, like that double bus bar scheme. Double breaker, double bus bar, it is costlier. 1.5 breaker scheme, because totally for each feeder 1.5 breaker scheme, different bus bar schemes, all this will be discussed later.